Okay guys, so the next question is find missing positive. So let us start with reading the question, but before that, this is marked as a Leetcode hard, but whenever you get a difficult question, I tell you, right, this is not that much of a difficult question. This is hardly a Leetcode medium. So let's start the question. This is quite simple to understand. Given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in order of n time and uses order of one auxiliary space. So you should use constant space, linear algorithm, it should be a linear algorithm, that is the time complexity should be order of n. And what does the question say? You will be given an array, it is unsorted, it is not sorted, right? And you have to return the smallest positive integer that is present in nums, that is not present in nums. So the first positive integer obviously runs from 1 till positive infinity, right? Within that, the first positive integer that is not present, you have to return that as the answer. So your output will be a single integer. It will be a single integer. If you just check this case, 0 is present, 1 is present and 2 is present. So the first positive integer which is not there is 1 is there, 2 is there, but 3 is not present. So your output is 3. Over here if you see, 1 is present, 2 is not present, and then 3, 4 is present. So basically 2 is the first missing positive, right? So you should return 2. After that, if you see, here are numbers where 1 is only not present. So obviously if the first positive number is missing, that is the result, right? So let us understand the question. The input and output is clear, I guess. I will just walk you through a simple observation, which is basically the main observation of these questions. Let us come to there. The observation is, guys, if you are given an array, if your input array is of size n, the array that is given to you is of size n, then your output, what is the range of output? Try to pause the video over here and think what should be the range of output. So if you carefully consider, the output range can be in between 1 to n plus 1, guys. Why? I am saying that if you are given an array of size n, okay, suppose you are given an array of size 5, for example, okay, the index runs from 0 to 4. Now you need to return the first missing positive number. Suppose in this array, suppose 1 is there, 2 is there, 3 is there, 4 is there, and 5 is there. There are 5 elements over here. So in this case, if an array contains, an array of size n contains all the numbers between 1 to n plus 1, 1 to n. If in an array of size n, all the numbers are from 1 to n, then your answer will be n plus 1. Obviously, if this is the input array, then the output should be 6. 6 is the first missing positive number. Obviously, if any number is not present among them, suppose instead of 40, 42 is there. So obviously the first missing positive number is 4. 4 is not present. In that case also it is between 1 to n plus 1 only. In maximum case, it should be n plus 1. That is the only observation that we should have, right? So I hope this point is clear, why your output should lie in the range of between 1 to n plus 1. If this observation is okay, if you're fine with that, now you can solve it using various approaches. Suppose the easiest thing that is coming to my mind is, if you are given an array size of n, you can make another array of size n. Obviously you are asked not to take any auxiliary space, we'll be coming to that approach. But if the last line of the question was not present, that you must implement an algorithm that runs in order of n time and uses order of one auxiliary space, then this can be one of the approach, that you take an array of size, suppose 0 to n, right? You take an array of size n, and after that suppose this is a boolean array, and you mark everything as false. For example, everything is marked as false, right? Now what you can do is, as soon as you find a 1, you can replace the I minus 1th index, because 0 should not be present. 0 is not a positive integer. So if 1 is present, you might think that 1 should be present over here. So this particular box over here in this array, this location of I minus 1, that is element minus 1 should be marked as true, for example. As soon as you find a 1, you mark the 0th cell as true. As soon as you find a 2, you mark this cell as true, like that. And then after that you iterate the whole array. Wherever there will be a false, whenever you get a false in the first, from index 0 to n, that plus 1 is your answer. I hope this approach is clear. Let me just give you a hint, give you an example, real example. Let me give you. Suppose you have given an array which is having 4, 2, 1, then suppose 8 and 7. This is the array that is given to you. So obviously the size of the array is 5. So you make an array of size 5. So 1, 2, 3, 4 and 5. So the indexes are 0, 1, 2, 3 and 4. And initially you fill everything with false. Okay. After that what you can do is, as soon as you get a 4, in index 3 you mark this as true. This index 3 as true. As soon as you get a 2, you mark the index 1 with true, right? After that you get a 1. As soon as you get a 1, you mark this index of 0 with a true, right? After that you get a 7, 8. 8 is not in range of 0, 1 to n plus 1. So you ignore this. For 7 also you ignore this. Cool. By the end of the iteration, this array will be ready. So as you iterate through this array now, you see there is a true at 0. So 1 is present. Then there is a true at 1. So 2 is also present. Then there is a false at 2. That means 3 is not present in the array. And as soon as you come across a false, you can return index plus 1. That will be your answer. This is one approach of doing it. But obviously you have to do it in constant space, and this approach is taking order of n space, because we are making an array which is the same size of the input array. If the size of the array is 10, you will make an array of size 10. If the size of the input array is 10,000, you need to make an extra array of size 10,000. It is linearly dependent upon n. So this is order of n space complexity. Now in order to optimize, the hint that you should get is, guys, obviously if you are given with any array, you cannot make an extra array. That means you have to do whatever you want to do, your operations must be in place. You should use the input array only in order to develop your algorithm. Now how can we do it? What I am saying is, in this array what I did, in index 0 I kept account of element 1. In account 1 I kept account of element 2. In index 2 I kept account of element 3. As you can see, in ith index I am storing the occurrence of ith element. In ith index I am storing the occurrence of I plus 1th element, right? Or I plus 1th element will be stored in ith index. This is the thing that I am doing. Now what I am saying is, this logic I can apply directly in the input array only. So basically what I am saying, if there is an array of size 5, for example, 0, 1, 2, 3 and 4, these are the indexes. Now if I have anything, suppose 55, then 1, then 3, then 4 and maybe a 5. Okay, suppose this, let me take 41 for example. Okay, so suppose this is the given array. Okay, now what I am saying is that if a 1 is present, it should be, I would keep it at index 0. If a 3 is present, or any number between 1 to 5, if we get any number between this range, it must be placed at their appropriate index if they are already not placed. By doing that, I can ensure that if any one of these elements are present, they should be present at their appropriate place. So whichever element is out of place, that particular index plus 1 will be our result. If you have understood, then it is fine. Otherwise, take one level closer. What I am saying, when I am iterating through this array, what I can do is, I come across 55. Now is 55 in range from 1 to n plus 1 or size of the array plus 1? No. So we ignore this. So 55 we ignore it. Then we come to 1. Should 1 be a part of this array? Yes, it should be a part of the answer. It should be a part of the answer, right? So what we do? We change their occurrences. We interchange the elements. So 1 if present, it should be present at index 0. Element is 1. I plus 1 is 1. So it should be present in ith index, right? I plus 1th element should be placed in ith index. So what do? We perform a swap operation. So as soon as we come across this 0th element, we ignored it. Then when we come across this 1, we interchanged it with the 0th element, because 1 is supposed to be placed at 0th index. So 1 comes over here, then 55 comes over here, rest of the element should be same. Now I should not, as soon as the interchanged element came to index 1, I should handle that case again. I should again check that the interchanged element that came, is that element also a part of the range of 1 to n plus 1? Obviously not, 55 is not in range. So now we skip again, we come to this 3. Now this 3 is in range of 1 to 5, and we check that it is already in the correct location. If 3 was present, it should have been placed at index 2. So let it be, we let it be. Then we come across 41. 41 is again out of place and it is not in range, so we ignore 41. Then 5, it is in range and it is indeed in the correct position, so we don't change it. Now we can iterate through this array again and say, check that in index 0 1 is present, so okay, no problem. At index 1 2 must be present. If 2 was present in this input array, after the end of the operation that I just explained you, after that particular operation of swappings, 2 must be placed at index 1. But as 2 is not present over here, we can safely say that 2 is not a part of the array and it is our first missing positive number. As simple as that. Let us look at some of the other examples, guys. Suppose there can be a possibility where 1 is there and suppose 4 is there, then 3 is there, and suppose then a 5 is there, and then another 5 is there. Suppose let us see this case over here. How am I handling the case? I am saying that I will be iterating through the first I will check 1 is there. Okay, 1 is already at its correct place, so we don't interchange it. Then 4 is there. 4 should be, if present, should be placed at location at index 3. So what do? We interchange them. So basically what happens? 5 comes over here, 5 comes over here, and 4 comes over here, right? 4 comes over here. As soon as I interchanged, I should now check for 5, guys. 5 is in range, but if it is in range, we should not perform the swap as like, if it is in range, we should check another condition before swapping it, that is already at index 4, that element is present. If yes, then we need not to swap it. It will be stuck in a infinite loop. This 5 will be transferred over here, and again the new 5, that is this 5, when it comes over here, that will be checked, and again you keep on transferring. So that should not happen, right? You should check that whenever you are putting it at some index, that index is already not been like the element at that index is not the correct index. You should make sure about that as well. So that is one point. I hope the logic is now clear, guys. Now programmatically, I will just, before starting with the code, I'll just tell you one thing, that how will you say that this 5, suppose I came across a 5, so this 5 should be present at index 4. So how can we do it? Suppose this array is named as nums. So how can you represent nums of 5 minus 1? At 5 minus 1 it should be present, right? So inside nums array, suppose you are at your I is 1, right? Your I is 1. So what you should do is nums of I minus 1. This is the content. This nums of I is your element. Nums of I is your element, and it should be placed at index nums of I minus 1. Nums of I is 5, basically 5 minus 1 is 4. This nums of I must be placed at index what? Nums of I minus 1. This is how you write it programmatically. Obviously you should be able to do it on your own, but so that when I write the code you don't face any problems, I am just telling you what this nums of I minus 1 is. If you want to place the element, suppose nums of I, you have a nums of I, you want to know that where it should be present. If it is in range, where it should be present. So it should be present at index this nums of I minus 1. At this index it should be present of nums array. That is another thing that I wanted you to visualize, right? Cool, guys. Let us do the coding. So what I am saying is, first let me calculate the length. Length is your nums.length. After that what do I do is, I take a variable I equals to 0. I am not using a for loop, I will be using a while loop, because at every iteration I am not going to the next index. As you saw, if there is a swap, the swapped element that comes, I should also check that element if that element falls at any particular place. If yes, we should also swap that particular element. So at every iteration we are not essentially doing like incrementing our value of I, right? So we'll use a while loop, and our while loop will run until we have reached our last element while I is less than n, right? Now here what do I do? I need to check when I am iterating through the array. First I need to check if the element that is present in the array at that particular index, if that element is indeed in range or not. Is it within 1 to n plus 1 or not? So what is the condition? Obviously if my nums of I, if the current element is greater than 0, then only it is a element that we should consider. Greater than 0, not 0 is not a positive integer. The positive integer range starts from 1, so it should be greater than 0, and obviously the answer range is, it should be less than equals to n plus 1, right? So it can be maximum of n plus 1, so less than equals to n plus 1. That means if my nums of I is greater than 0 and less than n plus 1, that means it must be accommodated at a particular index in our array. But if that particular index is already occupied with the correct element, then we need to check that condition as well, right? So what I am saying is nums of I should not be equal to, guys, it should not be equals to nums of, at that index that particular element should not be present. Nums of I not equals to nums of I minus 1. Let me quickly give you an idea about what this is. See over here what I am saying. See over here, as I told you that 1 is already present at the correct index. This 3 is already present at the correct index. So how can you understand? See, nums of I, suppose I is 2. So nums of 2, what is it? Nums of 2 is 3. In nums of 2, 3 is present. And let me check this is your left hand side, and what is your right hand side? Right hand side is nums of 2, I is 2 minus 1. Now if you do this, what is this? What is nums of 2? Nums of 2 is 3 only. Nums of 2 is 3. 3 minus 1, which is nums of 2. So nums of 2 is equals to nums of 2. So that is why this is the case where this condition basically check if the element that is present is already in its correct location, then you should not swap. Also this condition only handles this case of 5. If I find a 5 but already there is a 5 over here, then also this condition is this condition becomes true, that is it is not it becomes false, because this nums of I, which is 5, is equals to whatever the element is present in nums of 4, which is nums of I minus 1. So in that case also this condition will work properly and it will not allow you to swap. Basically we will ignore. If this condition matches, then only we will go inside and swap the elements. If this condition does not match, then obviously if the elements are equal, this would not match. This will be equals to, but we are checking for not equals to. So in that case, what I should do, if these conditions are true, that is the number is in range and it is not already placed at correct location, or at the correct location that number is not present. If these are the scenarios, then we should swap the numbers. How to swap? Obviously I will use a third variable. I will use int_temp to store the element at nums of I. Then at nums of I, I should put the value of whatever the value is there in nums of I minus 1. Instead of writing this whole, already as I have declared temp as nums of I can write temp minus 1. Actually I should write nums of I minus 1, but as this nums of I is equals to temp, I can write temp minus 1. I hope this is clear. After that, in this nums of temp minus 1, I should give the value of whatever I stored in temp. If this thing is done, then it will be swapped, but I am not incrementing my I. But if any of this condition is false, that is the number is not in range or already the number is there in correct place, then we can increment my I. We can increment our I, right? And at the end, after doing this, all the elements, if they are in range, they will be placed at the correct index. After that, what I can do, I can just iterate through the whole array. I equals to 0, I less than n, I plus plus, and wherever I find that the I is not equals to sorry, if my nums of I, the element that is present at the ith index is not equals to index plus 1, if this is the condition, that means that particular integer is missing, so I should return I plus 1. Now if this loop is also exhausted and we have not returned anything, that means the case is this 1 2 3 4 5, this case where the numbers are 1 2 3 4 5. If this is the case, then obviously at 0th location I am finding I plus 1th element, at 1 I am finding I plus 1, at 2 also I plus 1, 3 also I plus 1, and 4 also I am finding I plus 1. So the first missing integer is basically size of the array, which is 5 plus 1, which is 6. So at the end of this loop over here, if we still do not get a return, then we should come outside and return n plus 1, which is basically all the elements are present up till the length of the array and the next element is not present. That's why 0 number of times this condition was true. Okay, what is the problem? Okay, I cannot take int I equals to 0 because I have already initialized I. Okay, array index 1 out of bounds for length 1. If my nums of I is greater than 0 in line 6, nums of I not equals to nums of I. Okay guys, the number should not be less than equals to n plus 1, because for an array of size 6, for example, if for an array of size 5, I can maximum accommodate 5 only. 5 can be accommodated at index 4. I cannot accommodate n plus 1, which is 6, right? I cannot do that. So there should not be any equals to sign over here. If the number is between 0 to if the length of the array is 5, the number must be in between 1 to 5 only in order for me to accommodate over here. The answer can be 1 to 6. The answer can be anything between 1 to 6. But if the elements are between 1 to 5, then only we can accommodate. We should check for them only. So it should be less than equals to n or less than n plus 1, whatever you like. I hope this should work. Cool guys, bits 100%. That's it. Thank you.